All right, so this is the Unit 5 Assessment Study Guide. So what I've done is I've taken pictures of my work and I'm going to talk through the problems, all right? So here the first one asked me error analysis, and it gave me the problem 2x to the fourth minus 6x squared plus 10 minus parentheses 3x to the fourth minus 12x squared plus 5. And it asked me circle the step where the error occurs, describe the error in words, simplify the polynomial correctly, please show your work. So as you see here, I circled that second line because that second line is, and as I described in words here, they group the x squared values together with a minus sign on the outside, making the 12x squared be negative, which in the original problem, the 12x squared was not negative, all right? So then when I fixed it, I went ahead and I wrote like terms sitting side by side, making sure I kept those signs, that minus and the plus sign, and then when I simplified it, this is what I got for my final answer. All right, number 2 had 2 parts, and we are simplifying. This is where we're using those laws of exponents. So I showed you my first step here. So I went ahead and simplified negative 24 over 16 by dividing them both by 8, and I got a negative 3 on top and a 2 on bottom. My x's, I needed to just go ahead and subtract and leave it at the top, and I went ahead and moved that y to the 7th to the bottom to become positive. So here, my negative 3 and 2 stay in the same places because they're not going anywhere. 5 minus 3 is 2, and then I'm going to add these since they're both on the bottom part, and I got y to the 11th power. Over here, I had to do some work before I could jump into that, and so I went ahead and distributed that 3 through, which gave me a 2 to the 3rd and x to the 12th, because 4 times 3 equals 12. Down here on the bottom, I also got 4 to the 4th. I had to distribute, and x to the 12th, because 3 times 4 equals 12. So my x's went away because I had the same thing on top, same thing on bottom. They go away. Then I simplified 8 over 256, which simplified cleanly to 1 over 32. Number 3 said rewrite each in radical form. So if you're in my class, you know I remind you guys that this came from video 1. We didn't do much with it, but we are simply just rewriting. 5 to the 1/4 is the same thing as the 4th power, the 4th root power of 5. 3 to the 2/3. You keep the 3 squared there, and you're going to cube root it. I went ahead and simplified this. Both of these would be fine. Now you're going the other way. It says rewrite each in exponential form. Again, coming from the tail end of video 1. So here you have the square root of 3 to the 4th. So when you rewrite it in exponential form, you get 3 to the 4 over 2, which also is 3 squared. Again, both of these would be fine. Here I have a variable, x to the 5th, but we're doing the cube root. So it becomes x to the 5 over 3. All right, so here number 5 said write a simplified polynomial that represents the area of the outside walkway of the pool area. And I made sure to specify, just in case you're struggling, the pool is represented as the inside triangle. Well, here, and I know it's a little bit blurry on your paper, they gave you the dimensions. As you see over here, and again, I want to know what this area is. So to find this area, I need to take the area of the entire rectangle and subtract it from the area of this inside. And that will then give me the walkway. So here's my x plus 5, x plus 7. Again, I know area equals length times width on a rectangle. So I'm going to multiply them together. And my x plus 2, x plus 5, I squished in over here. I need to multiply them together. So when I do that, and I didn't show the box method, but that's what I got. I got an x squared plus 5x plus 7x plus 35, which is x squared plus 12x plus 35. Over here, you see what I get. But now notice, I still have my minus sign, and I included parentheses so that I would not lose where that minus sign goes. So now I combine like terms. X squared minus x squared, 12x minus 7x, 35 minus 10. And I simplified, and that was my final answer for the area. What is the resulting polynomial when 2x plus 3 is multiplied by 5x minus 7? So here I just showed a nice box method of this problem. 2x plus 3, 5x minus 7. I showed you the terms, and I simplified it on the inside to get 10x squared plus x minus 21. Good question number 7. Will the simplified form of the sum of two quadratic polynomials with positive x cubed terms always have an x cubed term? Explain. So when I was reading this question, as you see, I underlined 2 things. I underlined the word sum, and I underlined the word positive. So my answer was yes, because in this scenario, it mentioned sum, which means addition, and positive. So anytime you're adding 2 positive terms together, you would get a higher value of that variable. So you are still going to have an x cubed as your final answer because of that. Again, these two were the magic words. All right, number 8 said factor the following quadratic expression. What is the value of x? Because again, notice this has an equal sign equaling 0. So I'm just going to factor it. So again, I use that box method, put my x squared there, the negative 56 there, listed out my factors of negative 56, knowing that one of them is negative, one of them is positive, but that could be switched. Looking for a 10 when I'm looking at the difference, which is why I chose a negative 14 and a positive 4x. Pulling out my greatest common factor of each column and each row, and I ended up with the factored form of x minus 14, x plus 4. Then I had to take each one of these and set it equal to 0 to solve for that. So my final answer would be right down here, x equals 14 and x equals negative 4. All right, this one specifically, number 9 said solve the following problem by square rooting. So we wanted you to specifically use that method. Identify the zeros of the following equation, round your answer to the nearest tenth, which I see I failed because I rounded to the nearest hundredth on my paper. So the first thing that I have to do to both these sides is square root both sides. It's already in a nice pretty form. So then I ended up with x minus 6 equals plus or minus 6.32, okay? Because that is what square root of 40 is. Yes, you could have put 6.3. That would have been fine in this problem because they did say nearest tenth. Then I'm just solving them. I separated them to x minus 6 equals 6.32 and x minus 6 equals negative 6.32. Added 6 to both sides of these, and I get x equals 12.32 or 12.3 since it said nearest tenth, and x equals negative 0.32 or negative 0.3. Number 10 specifically said solve the equation using the quadratic formula. Round your solutions to the nearest tenth, if necessary, which as you can see on my answers, I did not. So you can round to the nearest tenth. So the first thing that I did, and again, this problem was set up pretty, is I identified what my A value was, my B value, and my C value. And then I started plugging it into the quadratic formula. And as you can see, I showed all my steps in that, showing where I got the 81, making sure that negative 9 became a positive 9. Identifying square root of 41, which I put as 6.403, separating it into the two problems, even doing that one step more, simplifying it, and getting a final answer, if I'm rounding to the nearest tenth, of 7.7 and 1.3. Number 11 asked me to rewrite the given function as the difference of squares. So here I have the problem, f of x equals x squared minus 121. Basically, all they're asking me to do is factor it. Difference of squares was one of the tricks that we learned, the shortcuts. It is simply x minus 11, x plus 11. If you wanted to go ahead and check it, you could draw the box method and multiply it out to see if it does indeed become that. But this was the answer they were looking for, okay? This is what they were looking for. All right, number 12 had 4 different parts, okay? But number 12 is what I was talking to you guys in class. It said, solve the equations using any method. For each, explain why you chose the method you did, okay? I did not write out the explanation, but I'll talk about it. So A said x squared minus 4x minus 45 equals 0. I went ahead and factored it, and the reason why is because I saw it was an easy, at least for me, factoring problem. You might say, I'd rather do it with quadratic formula, and your reason would be, I like quadratic formula. That is fine. You're still going to get the same answers. And as you see, the answers to that problem should be x equals 9, x equals negative 5. On B, the first thing that I did was I moved that 78 to the other side, and then I factored it. Now, this one was a little bit trickier because the factors of negative 78 were not so common, but I used my calculator. So again, and your answer should be x equals negative 13, x equals 6. Why did I choose it? Because for me, factoring was easier, okay? For me. You may again say, I want to do quadratic formula because quadratic formula is always right. I never make mistakes and life is good, okay? And that would be fine. You would say, because I like it. I'm good with that. C, okay? Again, now I put everything on the same side. But I went with quadratic formula. As you can see, here's my start, continued, move it over here, go there, okay, to get these answers. And my reasoning would be because immediately I saw dealing with this negative 3, I did not like the chances, and I knew the chances of getting negative 3 factors to get negative 7 were never as we see in the final answers with decimals, so I didn't want to do it. So that would be, I chose quadratic formula because I knew this was an ugly problem. Again, your answer could be, I chose quadratic formula because I like it, and that is totally fine. And then D goes with x squared minus 5 equals 44. I went ahead, I added 5 to both sides, and I got x squared equals 49. And then I didn't show it, but I square rooted both sides, and I got x equals plus or minus 7. So I chose the square root method because it was an easy square root problem. It was very clean. Number 13 said factor the following polynomial. So here you were giving a polynomial. You needed to rearrange it, okay? And then as you see, I showed over here, I factored it. So I had my x squared and my 60. I listed my factors of 60. And to get to 17x, I took a 5x and a 12x, and then I pulled out every greatest common factor of each row and each column, and that's when I got my factored form of x plus 5, x plus 12. Notice you cannot solve it because there is no equal to 0. So this is what it's looking for when it says factor the following polynomial. Divide the polynomials, okay? So here, as you can see what I did to show you, as we did in class, I went ahead and rearranged this problem to writing it as 3 separate problems, saying whatever that term was divided by 3x every single time. And then I did my simplification. Well, 27 over 3 is 9. X to the 4th over x would be x third, or x cubed. 18 over 3 would be a 6, and notice I kept that minus sign. X squared over x would be a remainder of x. 9 over 3 is a 3, and the x's cancel out, so that is why this is my final answer. Okay, so again, here they gave it to you in a different form, but still what you're going to do is you're still going to separate it into 3 problems. All right, 24 over 6, you see here, again, we're doing this now. This ends up looking a little different because 24 divided by 6 is 4. X squared over x squared, the x squareds cancel out. 18 over 6 is 3. The x cubed over x squared is remainder of x. 12 over 6 is 2. X to the 5th over x squared is x cubed. So it's in the opposite order of our standard form, but that's fine, and that would be the final answer for this problem. All right, Unit 5 performance events. Okay, so here's the word problem, the big word problem. A toy rocket is launched vertically upward from ground level with an initial velocity of 128 feet per second. Then its height, h, after t seconds, is given by the equation h of t equals negative 16t squared plus 128t if air resistance is neglected. A asks us about how many seconds will the rocket be 112 feet above the ground? And I give you these 2 answers. Now, you may be going, where do you get those 2 answers? Okay, so here is what I did. And as we practice this in class, here is what I did. I plugged in this equation into my calculator at my y equals. So I plugged in y equals negative 16x squared, technically is what it looks like in the calculator, plus 128x. Then I graphed it. So that gave me a visual image of what I was looking for. So again, they are asking me, how many seconds is it 112 feet above the ground? So I'm looking for the 112. After I graphed it, I then went to my table, second graph on my calculator, and I'm looking for 112, okay? And because again, a rocket's going like this, boom, okay? That's the whole point of the rocket. You see this shape, right? So they want to know, where is it at 112 feet, okay? Well, it gets 112 feet in 1 second, and you see that when you look at your table and your graphing calculator. And it also is at 112 feet at 7 seconds, because again, here is my rocket. Boom. So at 2 places, it's going to be at 112 feet. So I wrote in there, graph on calculator, use table feature on calculator, because that is legit how I did it, okay? There are other ways that you can do it, but then it says you want to prove that you are correct by utilizing a second method learned this chapter. Show your work below. I did not work out the math. I could work out that some other time or work one-on-one with you, but you could either factor, graph it, or solve by quadratic formula. I graphed up here, so for me, I would have to choose factoring or solving by quadratic formula to find this. And then C asks us, why is it beneficial to be able to solve problems by multiple methods? It helps to allow multiple methods to attempt when working with problems. Some are solved best by one specific type, while others can vary. And then having this toolbox allows for students to choose what is easiest for them or easiest for the problem. So, hope that explained it. Hope that makes sense. If not, definitely come talk to me. All right, good job.